All right, here we go. Did the bell ring? Seems like it's been a while. All right, listen up. So here's what we got going on. Obviously, the first thing you see up here is a whole bunch of red test days. So most school districts do this. 49 does this. They don't use this particular test, but they do some sort of, well, there's the state test, and then they do some sort of other testing during the year to determine what's your level of math and English knowledge. So we do the same thing. We were supposed to do this before, because we just didn't happen. NWE stands for Northwest Evaluation Association. It's just a company. And they give a math test and an English test. So you'll be taking, it's a computer test. It is, listen carefully what I say, it's not for a grade, right? It is to show you yourself, your parents, your teachers, administrators, how well you know these particular subjects. So it's important that you do your best on this, but it's not for a grade. So it's also a computer test. The whole thing's done on a computer, both the math and the English thing. And it's one of those tests where it tests every bit of your knowledge of math. So for instance, you guys know calculus. So when you get to those questions, you won't know what you're doing, right? So clearly you're going to get to a point on the, no, it's not going to ask you calculus questions, but it's certainly going to ask you questions that are above your knowledge level. And that's okay, right? But there's plenty of math that you do know, and so do your best on that portion. But it'll ask you questions, let's say in geometry. It'll ask you questions, easy ones, medium ones, and hard ones, and eventually you get to where I don't know what I'm doing. I've never even seen this stuff before, right? You guys know trig ratios? You don't even know what that is. So if you get a trig ratio question, well, it's a computer test, so you'll take a guess at it. If you get it right, it asks you another one of those questions, but more than likely you'll get it wrong. We have a lot of red up there. First off, we've never taken this test. I've never given this. My old school district, we called this test Scantron, and it was exactly like this. And it would generally take about 2 days for kids to take the test, right? Since you've never taken this test before, we're going to do a practice day. There's only like 6 practice math questions on it. But then we'll do a practice test. It's not a full test, but and we'll be talking during the whole time to get used to it. But we'll look at what the math test will look like and what the English language arts test will look like on this Friday. So no class on Friday. You're just going to come in. We're going to do a practice test. 3 of them. Coming back on, and then the English teacher will physically be here in this class during that time. Come Mondays when we'll take just the math test. Now there's 3 days for it. I don't think that we're going to be taking 3 days of test, but it's individually paced. It's not like, hey, here's a 30-minute test. It's you take the test until the computer says you're done. Some people will take 1 day. At my old school, I would have some kids that would take 3 days for them to finish the test. But I would have kids be done on day 1. So it's individualized. Like the questions you get may not be the questions that the person sitting next to you get. They may be completely different questions. They may be the same. But if this person knows more than this person on math, they're going to get harder questions than what you get, right? You're going to get questions until you start getting them wrong, and then it switches topics. So the 5 things it's going to ask you, basic math facts, a little bit of algebra, a little bit of geometry, a little bit of statistics, a little bit of graphing, like all those areas it's going to test you on. Don't be intimidated by this. You basically show up and you take a test. Do the best you can. We do have 3 days assigned for it. I don't know, all but a couple people are done by the 2nd day. On Wednesday, we'll start, afresh with normal lessons, and those couple people go to another classroom and finish the test. Yeah.
Will this sort us into different classes or anything?
No. We will be using this for that purpose starting next year, but not this year, right? And by next year, I won't need it for you, but for a new kid coming in, this is a good sorting thing. Yeah. No. No, they have computers for all of you. They're going to be one on every single desk, and we'll come in and we'll take the test. All right, so that's what it's going to do. So let's get started on the new stuff today. Neil is sending this out. All right, so everyone right now currently has A in my class. Everybody has an A. It's the start of a new quarter. So everyone has an A. Congratulations. Good job for getting your A. All right. Here's your homework. Copy down, please. By the way, since I also have you for essay, we're going to institute a couple new things in essay. First off is a planner check, meaning that we're going to every day inspect your planners. Now, what you use as a planner is entirely up to you. The only thing I'm going to say is if your plan on writing down homework is I write it down on a scratch sheet of paper, I stuff it in my pocket or in my bag, that's not a good plan. But if you want to use an actual planner, if you want to, I'm looking at Devin, he's just writing it down in his notebook, that's perfectly fine. But Miss Boyd and I will be inspecting every day in student advisement. It's the first thing we do as part of your grade, your planners. We've noticed just too many people missing assignments. Well, I didn't write it down. I didn't know what I was doing. So we're going to make this a part of your process. What we would really like for you to do is you take ownership of this. It's like, hey, I got a system and it's down. In fact, give me an easy grade. Yeah, look at my planner, whatever. But there's many of you, and I do mean many. I don't mean just most of you are doing this. Most of you are not doing this, right? So when you get to student advisement, we shouldn't have to write on the board what your homework is or what you're supposed to be doing. You should be able to open up whatever you consider your planner and say, yeah, I know what I'm doing. A couple other things, and we'll be doing student advisement starting this quarter too. Yeah, well, that's just simply not true. I mean, yesterday, all of your teachers sat in one room, all of your teachers, Maddie, sat in one room, and showing up to student advisement and saying I have nothing to do is complete and total falsehoods. Oh, there's certainly some classes you don't have anything to do, but the general statement of I don't have anything to do in student advisement is a falsehood that's going to die an ugly death quickly. No, I got you. I got you. So we talked about things like, when you're given a reading assignment, what should we as student advisement teachers be looking for? What questions can we ask of you to ascertain, that means to figure out, whether or not you are prepared for that lesson or not. So like for Latin, we say, hey, no, I don't have any Latin homework. Well, that might be true, but there's things that you can do in Latin. So we got a whole big list of stuff that when you tell us that you don't have anything to do, we got plenty of stuff for you to do. All right, here we go. So chapter 8 is actually a pretty easy chapter in the sense of we're going to be revisiting some material that we've seen before. Chapter 8 is on equations and variables, and what it really means is solving those equations. Okay, we did this in chapter 2, right? This is a revisit. You need, as 8th graders in math, to walk in and already be able to solve a 2-step equation. So that's why this book chooses 2 chapters to do the same thing. Although we've seen at the very end of chapter 2, we saw a little bit of 2 steps. This chapter really goes into 2-step equations. But it is basically solved. So today we're going to move our way back towards that task of solving. In order to do that, we're going to talk about, there's 4 of them, but we're only going to be talking about 3 of them. There's 4 big words in math. You look at any math test, no matter what the subject, from calculus all the way to 1st grade, it says one of these 4 words for every question. It either says simplify, it says evaluate, it says solve, or it says factor. It says one of those. And you can technically say there's a 5th one, graph. Right? But it's going to say one of those. So this year we don't see the word factor. You'll see it next year in course 2, pre-algebra. But you don't see factor at all this year. But we do see the other 3. So we're writing down one at a time. Box 1, I want you to write the word simplify. Box 1. The 3 words are simplify, evaluate, and solve. We look at them one at a time. So in box 1, I want you to write down the word simplify. All language arts teachers would be shocked at how math people define things. One of the rules in language arts is you never define a word by using the word. What is the meaning of table? Well, it's a table. That would never fly in a language arts class. But it flies in a math class. Simplify. It's the process of rewriting an expression in simplest form. Begs the question, what does simple mean? In general talk, it just means taking something that's very long and making it very short. 2 plus 4 is a perfectly fine expression, yet I can write that shorter. Instead of writing 2 plus 4, I can also write shorter. I can write 6, right? 6 is way shorter than 2 plus 4. That is what's called simplifying. Basically, I typically say simplify just means do the math, right? Just do whatever the math it says for you to do. This is not solving. This is not evaluating. This is not factoring. This is simplifying. What, do you want me to solve this thing? No, I don't want you to solve it. I want you to simplify it. Okay? The process of rewriting an expression in simplest form. Simplest just means in the shortest way possible to write it. Yeah, you could write 2 plus 4 as 2 times 3. It's the same thing. But 2 times 3 is, well, it's the same number of things. It's got 1, 2, 3 things. It's a 2, a plus, and a 4. It's 3 things. Or you can just write one thing. It's 6. Okay. We've seen simplifying for fractions. That just means reduce the fraction. 3/6 would be reduced to somebody?
1/2.
Okay. That's simplifying in terms of fractions. Simplifying in terms of fraction just means reduce the fraction. Questions? So there's the word simplify. So the first thing I'm going to have you do tonight for homework is do a little bit of simplifying. Now, in order to simplify, we need to remember the rules of PEMDAS. This is the year that we moved from PEMDAS to GEMDAS. And the reason being is because P stands for, G stands for grouping symbols. And the fact is we have more than parentheses that act like parentheses. We have a fraction bar that acts like a set of parentheses. Simplify the top, simplify the bottom. With a square root symbol, hey, do what's inside the square root symbol first before you take the square root. And those act as grouping symbols, not as parentheses. So therefore, this is kind of the year where I stopped saying PEMDAS, I start saying GEMDAS. Okay? Just so you know, G stands for grouping. You always do your grouping symbols first. That means all parentheses, all fraction bars. That means simplifying the top and the bottom of your fraction bar. It means do your square. You're not going to see square roots today, but you will next year. Do those. And there's a couple other grouping symbols that we'll talk about in chapter. Whenever we do negative numbers, we'll talk about the last grouping symbol that we'll see this year. It's called the absolute value symbol. It looks like parentheses, but they're not. M and D stand for? M and D stands for? And I told you back when we did this in chapter 1, I said, hey, me as a 7th grader, all I saw was the letter M and D, and I thought you do all the multiplication first, and then you do division. And that's not what it means. It means do any multiplication or division from left to right. Doesn't mean do the multiplication first and then do division. It means do all multiplication division from left to right. You might be doing division first and then multiplication, or vice versa, but you will go left to right. So get rid of all your grouping symbols, get rid of all your exponents. We won't see exponents today. Get rid of all your grouping symbols, which we will see. Get rid of all your exponents, and then get rid of all your multiplication and division from left to right. And then do lastly, it's always the last step, same thing with addition and subtraction. And we saw when we did this in chapter 1 and throughout the year that there are a couple of you kind of pick and choose how you do your math. You're not, even though I guess you can make up your own rules, you want to get to the correct answers, you can't pick and choose how you do this order. You must follow this specific order. You can't do subtraction first, even though it looks like it's an easy number. 4 minus 1, well, that's 3. But if that's not the first thing you're supposed to do, you're going to get to the wrong answer. Okay, this is the year PEMDAS turns into GEMDAS. So here are 3 quick examples, box 2. If you can do them together, go do them already, go ahead and do them. The first one is the one that most people miss, right? Why do I say that? Why do I say the first one is the one that most people miss? What do you got, Nathan? Now, why do you think people miss this one? Look at it, just sitting right there. They hear this, the kids that aren't really paying attention, they hear this left to right thing. They don't understand what it means. It means do all multiplication division left to right first before you do any subtraction addition left to right. They also, 10 minus 3 is easy, right? 10 minus 3 is, you really want to, it's like it's calling your name, do me first. But the problem is that PEMDAS, GEMDAS says do multiplication division first. So technically I need to do 3 times 3 first. 3 times 3 is, so this is really 10 minus 9, not 7 times 3. You see what I'm saying? This one's confusing? I mean, even in the next year, 8th grade, I have kids say the answer is 21. 10 minus 3 is 7. 7 times 3 is 21. When in fact, the answer is actually
1.
okay. Don't be that kid. I don't have people miss this middle one. Everyone gets this one. What do we do first? Jake?
Do the grouping symbols.
So therefore I would do
The 3 and the 2. Or just the 2.
where do you see a 3 and a 2?
Wait a second.
I'm looking at the
I
bottom.
know it's 2.
Oh, 2 plus 4.
Okay, which is
6.
okay. Do you do subtraction first or multiplication?
You do multiplication.
Okay, and like I said, the way this one is written, I had very few people miss this one because it's kind of written, do it from left to right, right? But when the first one, when it's not written that way, I'll have more people miss the first one. Sometimes 6 is 42. 42 minus 5 is 37. We good on that one? Macy, what do we do first and last one?
I'm gonna do the parentheses first.
Yeah, but there's nothing inside the parentheses. There's just a 2. Notice on this one we got a 2 plus 4. And this one there's just a 2.
We do 10 times 3.
Yeah, we do 2 times 3. We do multiplication before addition. So on the top, we're going to do 2 times 3. Madison, what do we do on the bottom first? It's on your paper, box 2. Well, what's on the bottom?
4 minus 2.
So therefore,
It's
2, right? So on the top, we do 3 times 2. On the bottom, there's only one operation. So there's nothing really to choose from on the bottom. But you can do on the top 1 step and on the bottom 1 step. What you can't do is, look up here, well, 8 divided by 2 is 4, and I don't know, write a 4. I usually don't see that in this class, but when I get to Algebra 1, I'll see kids do that. Say what? 8 divided by 2 is 4. 6 plus 8 is, and therefore the answer is, questions on what I just did? Everybody with me? Simplifying. It's one of the 4 big ones. Natalie?
It says 3 plus 2, not 3 plus 3, so it would be 5.
Where?
No, I didn't.
Okay.
I did.
Never underestimate your ability to screw something up, right? I don't know why, And here's the other thing about messing things up in math, is that you will convince yourself. She had completely convinced herself. And somehow when you convince yourself, you look at the problem, and you're like, yeah, I got it. Oh, no, I don't have it, right? I've never been able to figure that part out. Like, how do you stop yourself from being so convinced that you got it right when you clearly have it wrong? Yeah, good luck with that, Natalie, because I'm with you. I do that mistake all the time. Like, I'll stare at the problem like, yeah, 2 times 3 is 8. 2 times 3 is 8. 2 times 3, oh, it's not 8. Right? But somehow that's just the way your brain works. Yeah. All right. Box 3, we need to revisit fractions. Nathan, what do you remember about 3/4 times 8? How do we do that? No. How do we multiply? This was last chapter.
You multiply 8 by the bottom.
Oh, you're thinking this is a mixed number. Notice on a mixed number, the 8 will be on the other side. Now the 8's on the right side. What do you think? This is the less. You have done this before. Boy, this is causing a whole bunch of people issues. Everybody look at this. Who's got the answer? Devin thinks he knows what he's doing. You think you know what you're doing? What should I do as first step?
I multiply 8 times 3.
Okay, why is he said he's going to multiply 3 times 8? Why would he do that?
Because you don't multiply 8 times 4 itself, because 4 is your denominator, 4 is your multiple.
All right, How about I write this problem slightly differently so we can see what's going on? This is really 3 over 4 multiplication symbol 8 minus 1. See what I did? Does that make it more clear?
You can draw a little line.
What do you got?
You turn the 8 into a 8.
Danny says to make the 8 into a fraction. Why in the world would we do that?
So you can get the 1.
She's right, by the way. Why in the world would we do this? What's the rule, Danny, to multiply fractions? Multiply straight across. Tops with tops, numerators with numerators, bottoms with bottoms, denominators with denominators. So the reason why you put it over 1 is so you can do the multiplication. I'm just going to say, for all of you that are looking at that right there and saw a mixed number, woo, that's not a mixed number. That's multiplication. I see why you could think that, because if I put the 8 on the other side, now it is a mixed number. I've never seen a kid do that before, but I can see why that would be confusing. All right, so let's see if we can do this now. What do we do first, subtraction or multiplication? Okay, you want to cross reduce or you want to just multiply straight across? No, so he wants to multiply straight across. 3 times 8, 4 times 1. So she gets 24 over 4 minus 1. 24 over 4 is actually the number. So 6 minus 1 is, okay. I cross reduced, right? 4 goes into 4 once, 4 goes into 8. Multiply straight across, and I still get 6 over 1. Stop me if you're lost. Why did I write 10? How come I didn't catch that first period? Nobody in class caught that. I don't know. That should be a 1. That should be a 1. Now it's a 1. Okay. These are not the droids you're looking for. Oh, look at that big honking 1 right there. This is a 7th, 8th grade problem right here. The fraction bar acts as the G, the E, the M, the D, the A, the S. The fraction bar. What does it act like? It acts as both the G and both the D. It acts like a grouping symbol in the sense of I got to do the entire top first or the entire bottom first before I even think about that the fraction bar is a D. All right, attention up here, please. You do realize that they're building a whole new building onto our building. All right. Just be thankful you're not right now in Miss McCullough's classroom and they're pounding on the walls, right? All right. Who do you take English with? Miss Coleman. In Miss McCullough's classroom, they're right next to where they're. Yeah, they took their windows away. Okay, so back to this one, we're going to do the fraction bar first. So what do you want to simplify, the top or the bottom? It doesn't matter which one you do first, top or bottom. Bottom. 2 times 3 is, oh, that was easy. How about the top? What do we do first? It doesn't, no, the grouping symbol says simplify the top and bottom first before you do any of the division. Okay, so now we got to simplify the top. What are we doing first on the top? Inside the parentheses first. So it's kind of like it's PEMDAS inside of PEMDAS. 10 plus 2 is 14 minus 12 is, therefore the answer is, stop me if you're lost. And yes, as Maddie said, we were still doing review. I mean, we've done this before. We have not done one as complicated as this one before, right? We've probably done that one before, but we've not done this one. This is where chapter 1 starts next year. Like one's just like this. Chapter 1 and course 2 is reviews now. Okay. Well, we go on simplify. Tonight for homework, they're just going to give you ones just like this and ask you to simplify. Okay. 3 main words: simplify, evaluate, solve. We haven't done evaluate or solve, but we just did simplify. Okay. Simplify just means follow PEMDAS, do order of operations, do the math. All right. Second word, evaluate. Write this down, please. Box 4. Evaluate. I'm going to give you an expression. That expression is going to have letters, variables in it. And I'm going to tell you what to write in place of those letters, the variables. That process is what's called evaluation. Two parts. First part is it's the process of substituting. In other words, you're going to erase the variables and you're going to put in values. I will tell you what values to use. The second part is, well, what we just did, simplify. Evaluate is the fancy word for it. Most math teachers say plug and chug. Plug and chug is the process of you plug in numbers into the variables and you chug through the calculation. The process of substituting value, now it's just parentheses S. Sometimes there'll be more than one letter variable that you'll be dealing with. So it could be one letter, could be two, it could be an X and a Y. Next year there will be 3 letters, maybe even 4 letters that you will substitute for. The process of substituting values in a variable expression and then simplifying. So it's a twofer. 2 steps instead of 1. What we just did, simplify, with an evaluation portion where we substitute values. Well, what does that look like? Well, visually it looks a little weird. You see this? What's weird up there?
The X's.
Don't like those X's. What else looks weird? The semicolon, right? The semicolon separates the expression on the left, and almost universally they put the expression on the left. I can't think of any time that they wouldn't. They could. On the left, and on the right side, it will tell you what to substitute. Laura, what's it say? Just read. What does it say? Oh, everything to the right of the semicolon. It says, if you see the letter X, you're going to. If you see the letter X, you're going to. I'm going to use 3. That's what it says. That's what it means, right? It says X is equal to 3. But what that means mathematically is that if you see the letter X, you write 3. Now we go to the left of the semicolon. Do you see an X? So what are you going to do? You're going to write 3. Now I'm going to add one extra step. I want you to put parentheses 3. Okay? Why am I asking you to put parentheses? If I didn't put parentheses, guess what you would write?
23 plus 4.
I would write 23 plus 4. This doesn't say 2x, it says, technically, it says 2 times x. So with the parentheses, with my substitution, right, now it says not 23, but 2 times 3 is what you're supposed to say. It's supposed to say 2 times x. It does say 2 times x because x is now the value 3. Who's lost the one I just did? Because if you don't put the parentheses, it literally is, the answer is 27. With parentheses, the answer is, try it again.
10.
With parentheses, the answer is 10.
So,
You got to tell me how you got that number.
so X is 3.
Oh, okay, now it makes sense. Where's she getting now? I'm trying to figure that part out. All right, who's lost the one I just did? It's called plug and chug. You plug in the number, chug through the calculation. You do have to use PEMDAS. All right, these can become confusing only because the spaces are probably. If it was me, I put bigger spaces between the semicolon. Because sometimes you're looking at this and it's all squished together. Which one?
The line at the bottom.
All right. All right, so the first one, work ahead of me if you can. If not, work with me. The first one says 3n minus 1, and it says if I see the letter n, I'm going to write 5. Well, I see an n, so I'm going to write parentheses 5. Without the parentheses, it's 35 minus 1. With parentheses, Nathan, it is, he's giving me the answer. It's 15 minus 1, which is 14. We okay? Remember order of operations. First one, I generally won't see anyone make a mistake. I will see plenty of people make a mistake on the second one. It says 9 minus 2e, but it says if I see the letter e, I'm going to
3.
write a 3. Why do I say that people will make a mistake for this one?
Because they'll do 3 times 2.
Or they'll think 3 times 7.
They'll see this 9 minus 2, and since that's really easy, they will say Well, that's the answer is 21. We'll do 9 minus 2 is 7. 7 times 3 is 21. It's an easy mistake to make. But by GEMDAS, PEMDAS, I got to do multiplication before I do subtraction. 2 times 3 is 9 minus 6 is not 21. Like, where's he getting the 21? If you do it wrong, 9 minus 2 is 7. 7 times 3 is 21. You do this wrong, you get 21. And I know why you make the mistake is because you're just a 2 always going left to right. Well, you do left to right for multiplication division. You do left to right when you do adding subtracting. But when you combine adding subtracting multiplication division, you got to do all your multiplication division first, left to right, and then do your adding subtracting left to right. Grace, last one. What do I do?
Change the ends.
Okay.
And then put the one under. Did you do the fraction?
Yeah, let's do a fraction first. Because remember, the fraction really means, that symbol means,
Division.
it means division, right? We do division before subtraction. 10 divided by 2 is
5.
Therefore, the answer is
2.
good job. Yes, everybody.
Yes, just a second.
I gotta actually take my camera, my phone, and take a video right now.
For what?
You guys are dead.
I just have a question.
No, I know. I'm just saying that.
We're tired. We don't want to be
Clearly,
tired and hungry.
clearly, yeah, Danny.
So like homework like for it has like these.
We haven't done that one yet. We will. We're about to do those. All right. Box 6. I'll give you a 20-second head start, and I'll walk you through it. Get started on box 6. Everybody good? Everybody struggling with this?
No.
Okay. Danny's looking at the homework. She's like, "What is this symbol? I don't even know what it means." Next Monday on the test, you're going to get to symbols and you know what they mean. That's because you haven't been taught it yet. But as soon as I teach Danny this symbol, she's like, "Oh, that's what you do? Okay, I got it." So much of math is like that.
I'm so tired.
No, you're Madison. If your parents made you, "I'm so tired," then shame on them.
I know, that ain't mine.
I wish they did.
You better like 10, 15.
It's 11 right now.
No, at night. I went to bed.
I did too. I usually go to bed way earlier than 10:15, but I went to bed 10:15.
At 9. Oh, I would my phone up at 9:30, then I would watch TV till 10, and then I would watch movies till 11.
I was watching
You got all 3 done, Madison? Maddie, which one are you on?
I'm being bored.
We're on box 6. Sure. But give me a second there. All right, Sam, walk us through the first one. Go.
Okay, so the C goes for 8.
And just remember to put that in parentheses so it doesn't look like a 28.
Yeah, and then it's equals 16, and then it's plus 7, and then that's. I'm minus instead of.
Sometimes the brain works in strange ways, but she got all the way to the last step. All right, good job. 23. All right, who wants the middle one? What do you got? Macy, here.
I put 2 over 3 within.
And so this is now a mixed number, right, Nathan? We make that be a 9? It's a mixed number? No, good job. All right. I see why you would think it would be a mixed number. All right, keep talking.
All right. And then you cross reduce.
She's going to cross reduce. You don't have to. I always say cross reduce to make your life easier. I would cross reduce as well too.
And do 1 and 3.
Okay. Therefore, that gives us
2 times 3 and 1 time.
which gives us
Oh, sorry. 5.
2 times 3 is not 5,
6 and 1.
which is basically the number.
6.
Okay. Last one. Who wants it? Oh boy. You guys are truly dead.
What?
Oh, sorry.
I died
Jeez,
yesterday.
Good for you.
All right, Nelius, last one. Talk me through.
So, we're alive, everybody. 2/5 times.
Can anybody hear Nelius? Because I can't, so you guys are talking.
So it's gonna be 2/5 times 15/1.
Times what? 15 over 1.
15/1.
Okay.
Plus 5.
Okay.
And then you can possibly just divide into 15.
Excuse me,
Yes, ma'am.
can I have Devin to the office, please? He's coming back.
He's on his way.
Thank you.
All right, so Nelius said he's going to cross reduce. The 5 turns into a 1, and the 15 turns into a. Okay. Therefore, we get
6
over
1
plus 5, which turns into
11.
11. 6 over 1 is 6. 6 plus 5 is 11. Good job. Yes? We got evaluation? So there's 4 words. Simplify, evaluate, solve, and factor. We're not doing factor this year. Okay? Graph would be the 5th one if we throw that one in there. All right, so of the big 3, really it's 4. Now we're going to talk about, and that's what the rest of the chapter is about, solving. Now, please write this down, please, in box 7. Most kids, when they say do math, they always say, do you want me to solve this? The only time you actually do solve is when there's an equation and a variable, and you tell me what the variable is. For instance, x equals 2. If that's not your answer, like on the previous ones, hey, the answer is 4 or 5, you're not doing solving. Solving is the process of determining what value of the variable in that equation makes the equation true. When you say, I solved it, and I say, well, what's the answer? And you say 3, you haven't solved it. You got to say, when x is 3, that makes the equation true. And I don't mean you literally write those words out. All you write is x equals 3. But when you're solving your last step, the answer, it should say x equals answer. By the way, what's the answer here? X equals
8.
X doesn't equal 8.
8 equals 4.
X equals 4 is the answer. We'll talk about the process here in a second. But this is what solving looks like. As you do some stuff, this is the algebra, and at the very end, you tell me what x is, going back to the original one, what x is to make that true. There's only one number that makes this one true, that's 4. When x is 4, this is now a true sentence. Yeah. Variable, that means 11. The process of determining what value for this equation makes it true. There's only one number, and that's when x is 4. If x is 3, you get 6 equals 8. Well, that's not true. If x is 1, you get 2 equals 8. That's not true. But when x is 4, 2 times 4 is 8, you get 8 equals 8. That's true. Now, what's that process? That process looks like this. Remember back chapter 2. Hey, where's the variable left side? What's attached to? How is 2 attached to x? Attached by multiplication. How do you get rid of multiplication? Divide. You divide both sides by 2. That gets us our answer. This is what, ladies and gentlemen, we'll be doing this chapter. By the way, not 1 steps, but 2 steps. And if you're good at this, we'll throw in a couple, 3 steps, 4 steps in there as well too. But our goal is that all of you can solve a 2-step equation, 90% of the time.
90.
Well, it's algebra. Everyone makes mistakes in algebra. But you should be able to do all the steps or know what steps to do. The math of the steps is generally where we see mistakes. Occasionally, in 7th grade, I'll get kids that don't know the steps occasionally. But most of the mistakes will simply be, literally, they'll do 8 divided by 2 and write 6. That's not an algebra mistake. That's a calculation mistake. All right, so that's the process of solve. And we did this in chapter 2, okay? We've solved 1 step, so we also briefly solved 2 steps, okay? This chapter is all about 2 steps. So even though we'll revisit 1 steps tomorrow, we will spend majority of our time on 2-step equations. All right. Now, this is kind of a side note. You know, I've made big statements in the past about how math is very accurate, logical. We don't like having extra steps. We like doing things elegantly. Here's an unelegant thing. We have two other words for solve. These are the two words, satisfy and solution. They both basically mean solve. We just use them in everyday math speak. We'll say, what number satisfies the equation? Well, it just means what number makes the equation true. But you'll see this tonight for homework. You'll say, what number satisfies the equation? It just means solve the equation. When you solve the equation, the answer is called the solution. It's the number that makes the equation true. Nathan, write both these down. Satisfy, it's when a value makes a variable equation. It just means what number makes it true. A solution, well, once you find that number is the solution. And why don't you just say solve? Well, I agree, but you'll see these in all math books. I even occasionally use the word satisfy. Hey, what satisfies this equation? More so in higher level math than 7th or 8th grade. But in high school, I'll say, hey, what satisfies the equation? I'm kind of double speaking. What I'm really asking the student to do is solve the equation. So why don't I just say solve? I'm guilty of this as well too. And, well, here you go. Here's your definitions in 7th grade. All right. So I'm not going to spend too much time on it. By the way, what number satisfies this equation? 4. 4 is the solution. 4 satisfies the equation, right? All right, so 4 is what satisfies and is the solution to the equation. So if you see this in sentence form, we would say 4 satisfies the equation or 4 is the solution. All right, enough of that. Tonight for homework, you're going to see a question that looks like this. It kind of looks like what we just did with evaluation, right? The semicolon. But notice on the left side now we don't have an expression, we have an equation. Still kind of looks the same way. And by the way, you do it exactly the same thing. You plug and you chug, right? You're going to plug this number in every time you see an N. You're going to see if it makes it true or false. It doesn't always make it true. Okay? So it says, does it satisfy? This is going to be a yes or a no answer. So does N equal 5 make this true or false? Anybody? Does it make it true or false? Well, how do you know?
2 times n.
Because you do the evaluation, right? You plug in the 5 and see if it makes it true. 2 times 5 is, and 10 minus 1 is 9. So yes, 5, so the answer for this would be yes or no. Jay, does 4 satisfy that equation? Tell me what you would need to do to get to that answer. By the way, this is box 9 on your paper.
Just realized that. Sorry. So yes.
Yes is the answer for the top. So what would you have to do to figure out whether it satisfies the equation? Plug and chug. So tell me what you would do. I'm going to take this value, which is
4. Oh my god.
and then
So that would be 2 times.
plug it into the, not the expression this time, but the equation, and see if it makes it true or false. Does it make it true or false?
It makes it.
Do the math.
Yeah.
Do the math.
Oh. So 2 times 4 is 8. 8 plus 5 is 13.
And 13 clearly, at least in our universe, is not 17, right? So does 4 satisfy this equation?
No.
Yes or no answers. Who's lost? I mean, it's literally what we just did, right? With an expression, except now we're doing it with an equation. And we're using the word satisfies or solution, right? All right. Yes? This wasn't Nanny's question. Nanny's question was this last idea. Ready? Write this down, box 10. Instead of one possible answer, now they're going to give you
3 or 4.
more than one. Right? I think it's 3. Can I throw them?
There's a couple that are 4.
There's a couple that are 4. Okay. They're going to give you 3 or 4 possible answers. Guess what you're going to have to do?
Try all of them.
Until you find. Oh, but by the way, guess what? None of them could be the answer. That is a possibility. But if you plug in the first one, it's the answer. Do you need to check the other ones? No. Okay. So our goal here is to find which one is the answer, which one satisfies, which one is the solution, and once you find it, you're done. Unless it asks, are these numbers the solution or satisfied? And you yes, no, yes, no. But usually it just says which one satisfies. What? I agree. A lot of times in math, it's really easy. It just needs to be explained what they want you to do. Nathan? 1 second. Yeah.
So I think I figured it out, but would we write like the variable?
Just whichever one makes it true is fine.
Okay.
All right. So let's see. Does one make this one true or false? This is box 10. Does one make this true or false? 2 times 1 is? Plus 4 is? Not 10. 2 times 2 is? Plus 4 is? Not 10. 3 times 2 is? Plus 4 is? So the solution, or what satisfies that one, is 3. Okay? That's how it's done. All right, let's do box 11. Here we go. Does 4 satisfy it? You can kind of do this one in your head, right?
No.
8 minus 4 is?
4.
Well, not 2. 8 minus 5 is? Not 2. 8 minus 6 is? So what satisfies this one? 6. Now, there's the math behind it. But n equals 6 is what I've determined what value in the replacement set makes the equation true. 6 makes it true. Are you guaranteed that one of these is the answer? Okay, last box. Does 0 satisfy this? 2 times 0 is? Does 17 equal 25? Nope. 3. 2 times 3 is? 6 plus 17? Not 25. 2 times 5 plus 17? Do any of these satisfy? So what's the answer?
None.
In math, instead of saying the word none, we put no solution.
Would you kind of solve if we put none?
No. So this is your classic easy problem, but it needs to be explained to you why we use this notation. All right, any questions? All right, that's it. Eleanor, are you online? Questions?
No questions.
Okay, we'll end it right here.
Okay, bye.
See you later.